want to take statistics. It's boring and I'm never going to use it.
Incorrect, my fellow college student. Statistics can be fun and you will use it.
Who are you? Why are you here?
Start off with what a statistic is. Our savior Wikipedia says that a statistic is the discipline that concerns the collection, organization, analysis, interpretation, and presentation of data, which is a very wordy way of saying comparing information to other information and interpreting it. For example, a studied statistic could be, is there a difference if I drink 20 Red Bulls in an hour before working on an essay? And if I don't do that before working on an essay? Then you got statistical inference. As the great Wikipedia also says, statistical inference is the process of using data analysis to infer properties of an underlying distribution of probability. The inference is pretty much looking at a population of people and coming up with a hypothesis so we can make generalizations of the population we selected. Looking at the data and creating our interpretations. Take this group, for example. My hypothesis is that they will report that they feel better after seeing a picture of a cute animal. See, we got our data, but what do we do with this data? Let's start with our null hypothesis. A null hypothesis means that there's no difference between the two sets of data, implying no correlation. Our cooler alternative hypothesis means that there is a difference between the two data sets, implying a correlation.
That's cool and all. There's clearly a difference, so you can leave now?
Absolutely not. We're just getting started, for we love data in this household. Let's start by getting the sum of our x and y values. So this E-looking thing is called a sigma, but it really just means the sum of all the data it's referring to. For example, the sum of x is 1 plus 3 plus 5 plus 7 plus 0, which equals 16. Sum of y is 10 plus 7 plus 9 plus 6 plus 1 equals 33. Now, how do we compare them? I hear you asking, but trust me, we'll get there. But first, more math! We are going to find our sum of squares for our x and y values. Now, sure, we could take the long way of the definitional formulas, but we're cool because we're taught by Professor Bridget, so we're going to use the computational formulas. Woo! Here we see our favorite E-looking friend. But what's this? Why is one the EX friend in parentheses and the other is not? Well, you see, sigma x to the power 2 is another part of the whole deal. It makes our lives easier because instead of going through each data point by hand to find some of square, the calculators do all the hard work. Now let's get back to our formula. But what's this? N? N is our sample size. In our case, we have a sample size of 5. Now hold on to that data because now we're going to find our sum of products. To start with, our sigma xy is multiplying the values of x and y against each other and adding them up. So it'll look something like this. And so we take all this information, we put it into our SP formula, and it'll look something like this. Now time for the Pearson correlation, which is usually referred to as R. We're going to round our R to 0.31. Now, to find out if our correlation is strong, we are going to compare it to a Cohen's d table. But first, we must square r. So r squared is 0.0961, but for this ease of math, we're going to say that it is 0.09. So r squared is 0.09, and comparing it to the table, it states that our data has a medium effect. So what does this all mean? Well, first, we get to reject the null hypothesis because there is a difference in our data and it does not equal 0. This means that we can accept our alternative hypothesis because there is a difference in our values. This also implies that there is a medium correlation between our data, which essentially means that yes, it is likely that showing a cute image of an animal will improve someone's mood. See, statistics can be fun.